Let's do one problem. A wave travels along a straight horizontal rope. The vertical distance from crest to trough for this wave is 16 centimeter, and the horizontal distance from crest to trough is 22 centimeter. What are the wavelength and the amplitude of this wave? So let's make a sketch at first as a rule of this problem solving. So wave is traveling and it's crest and trough, so I can make a wave as a transverse wave. So what is given is the vertical distance. The vertical distance from crest to trough A of this wave is 16 centimeter. So this is crest and the bottom one is trough. So distance from this crest to trough on the bottom, that is given 16 centimeter. Now what is given other? The other one is given the horizontal distance from crest to trough. So this is crest and this one is trough. So the horizontal distance from crest to trough is 22 centimeter. This is not a scale, so just I'm making a scale. So I'm making a distance, so this is not in scale, okay? So you know that we have to calculate wavelength and amplitude. So the wavelength is distance from crest to crest or from trough to trough. So distance from crest to trough, nearest trough and crest distance is half of wavelength, because distance from two consecutive crests is to the wavelength lambda. So in our case, we have to calculate wavelength lambda is equal to what? And we have to calculate amplitude A is equal to what? So in problem A, so from this figure, we can say that 2 lambda is equal to 2 times 22 centimeter, because 22 centimeter is distance from crest to trough, and which is half of the distance from crest to crest or from trough to trough. So if we solve this, we'll get 44 centimeter. 44 centimeter is wavelength. Now V. Now we have to calculate amplitude. So amplitude is distance from mean position to maximum displacement point. So here is horizontal line from starting from O. This is mean position. So from mean position to crest or mean position to trough, on the bottom or on the top, that is equal to amplitude. So in our problem, it is given distance from crest to trough, which is vertical distance, is 16 centimeters. So this is double of amplitude. So amplitude is equal to 16 centimeter, which is from the top of the crest to bottom of the trough, which is twice of amplitude. So amplitude is half of that. So that is 8 centimeter. So in picture, I can make a sketch on the bottom is if you have this type of transverse wave, this is crest, this is crest. So distance from crest to crest, this is wavelength, and distance from mean position to crest on the top, which is vertical distance, that is amplitude, or from distance from mean position to trough on the bottom, T, that is amplitude. So in our problem is given vertical distance from crest to trough, which is double of amplitude, and in horizontal direction, it is given distance from crest to trough only, so which is half of the distance from crest to crest. So wavelength is double of that.